Let's discuss the condition for constructed interference. Let y1 and y2 be the two waves. Y1 is a sine omega t and y2 is b sine of omega 2 plus omega t plus phi. According to superposition principle, when these two waves are incident at a certain point, isn't it? The resultant displacement is sum of the individual displacement. So y is equal to y1 plus y2. Just insert the value of y1 and y2 here. You get a sine omega t plus b sine omega t plus phi. Isn't it?
Yes, sir.
As you know, you are acquainted with this formula sine a plus b, that is sine a cos b plus cos a sine. Just expand this term here, you will get this thing here. Isn't it?
Yes, sir.
You have to rearrange the terms. Just take sine omega t common. You can find this guy within the brackets a plus b cos phi. And moreover, when you take cos omega t here, you can get b sine phi.
Yes, sir.
Now we will make certain approximations here. A plus b cos phi, that is equal to r cos theta, and b sine phi, that is equal to r sine theta. Mark these equations 4 and 5. You just square and add equation 4 and 5, you will get r is equal to a square plus b square plus 2ab cos. I will not get into the mathematics that is involved in it, isn't it? That is too easy and that is not so intricate. You can get it easily, isn't it?
Yes, sir.
I think you are not confused with it. As far as these waves y1 and y2 are concerned, y1 has amplitude a and y2 has amplitude b. Obviously, if I denote I1 is the intensity of the wave 1, you know intensity that is proportional to scalar amplitude. Intensity is proportional to scalar amplitude. Therefore, what is the intensity of wave 1? That is Ka square.
Yes, sir.
While K is certain constant.
Constant.
And moreover, if you have to find the intensity of the wave that is represented by y2, its intensity will be I2. That is proportional to this amplitude, so you can write it K b square.
Yes.
Now we are interested to get what is the intensity of the resultant wave. What is the intensity of this resultant wave? Obviously, if I denote the intensity of the resultant wave, that is I, that is obviously proportional to square of its amplitude. So its amplitude is R, so you can write simply K R square. Isn't it?
Yes, sir.
So what is intensity of the resultant wave? That is K. You just insert the value of R square from equation 6. That is A square plus B square plus 2AB cos of phi. You can write intensity of the resultant wave K A square. You just multiply by K B square plus 2AB K cos of phi. Since K A square, that is the intensity of the wave Y1, so you can write
Yes,
I is equal to I1, Kb square, that is the intensity of wave Y2, that is I2, and 2AB K cos of phi. Now I have to get what is this factor here, isn't it?
Yes, sir.
You know, what is intensity of wave 1? That is Ka square. What is intensity of wave 2? That is Kb, isn't it?
Yes, sir.
You just multiply what is I1 and I2. If you multiply it, that is K square, A square, B square, isn't it?
Yes, sir.
You can write I1, I2. That is K, A, B whole square. So what is K, A, B? That will simply under root I1, I2, isn't it?
Yes, sir.
That will simply under root I1, I2. Let me rub it off here. So what will the resultant of intensity of the resultant wave from this expression? So you can write I is equal to simply I1 plus I2 plus 2 under root I1 I2 cos of phi. Isn't it?
Yes, sir.
Isn't it?
Yes, sir.
Any confusion?
No, sir.
Now we will discuss when will be the intensity maximum or when the intensity will be minimum. If you have a cursory look on this expression, that's the intensity of the resultant wave, you can find a factor cos phi here, isn't it?
Yes, sir.
So the whether the intensity would be minimum or it would be minimum. It wholly and solely depends on this factor cos phi. You know, if cos phi is maximum, intensity will be maximum, and you are acquainted with the notion that cos phi is maximum and its maximum value is 1, that is plus 1. When you obtain cos phi having its maximum value plus 1, you know, when cos phi is equal to an even multiple of pi, cos 0, cos 2 pi, cos 4 pi, isn't it?
Yes, sir.
So cos and cos will cancel out, so phi will be 2 and pi. Here n is 0, 1, 2, 3, so on and so forth. So the two waves, y1 and y2, they will interfere constructively. They will interfere and you will obtain a constructive interference. You will obtain a bright fringe on the screen if the phase difference between the two waves is an even multiple of pi.
Yes, sir.
Is an even multiple of pi. Moreover, if we have to find what is the corresponding path length, what is the corresponding path length between the two waves? If I denote path length, it is x. If I denote path length is x. What is the relation between path length and the phase difference? That is lambda by 2 pi into phase difference. Into phase difference. Are you getting it?
Yes, sir.
We obtain the phase difference between the two waves. When the phase difference is an even multiple of pi, is an even multiple of pi, you get a bright fringe on the screen. You get a bright fringe on the screen. Moreover, I mean to say, what will be the corresponding path difference between the two waves so that you could obtain a constructive interference. The relation between path difference, if you denote a path difference by x and a phase difference, the relationship between path difference and a phase difference is lambda by 2 pi into phase difference. So what will be x here? That is lambda by 2 pi. What is here? Phase difference. That is 2 and pi. 2 pi and 2 pi will cancel out, so you get n lambda simply. N is 0, 1, so on and so forth. So, when you will obtain a constructive interference, either the phase difference has to be an even multiple of pi, or the corresponding path difference is an integral multiple of lambda. Is an integral multiple of lambda. Isn't it? Are you getting it? Now we will obtain a condition. When will the intensity minimum? When cos phi will be minimum. Just have a look on this very expression. What is it? It is the intensity of the resultant wave. We obtain a condition when cos phi will be maximum. We will get a constructive interference. The intensity will be maximum on the screen. Isn't it? Intensity will be maximum on the screen. You obtain a condition for constructive interference. What is that? Either the phase difference is an even multiple of phi, or the corresponding path difference is an integral multiple of lambda. Moreover, if you have a look on this expression, when you will obtain a destructive interference, when cos phi is minimum, and the minimum value of cos phi is minus 1. Minimum value of cos phi is minus 1. And when you will get when cos is an odd multiple of pi, cos pi, cos 3 pi, cos 5 pi, cos 7 pi, so on and so forth. On these occasions, you will get cos value having minus 1. Here n runs from 1, 2, so on and so forth. Cos and cos will cancel out. What is it? 2n minus 1 into pi. This is the phase difference. And more importantly, what will be the corresponding path difference? What will be the corresponding? So that you could obtain a destructive interference. That is lambda by 2 pi into phase difference. Into phase difference. So x will be lambda by 2 pi into what is phase difference for destructive interference? That is 2 and minus 1 into pi. You can evaluate it a bit. just take 2 here multiply outside, that will be n minus 1 by 2 into pi. This 2 pi and 2 pi will cancel out, so it will be n minus 1 into lambda.
Lambda.
So n runs from 1 to so on and so on. This will be the corresponding power difference for the waves, so that they could undergo a destructive interference. Is it okay?
Yes, sir.